Hi, myself Manjunath from the Department of Electrical and Electronics Engineering of KLSVD IT Halyal welcomes everyone for this session on the subject testing and commissioning of the power system apparatus, which is the professional elective for the 7th semester with the subject code of 17EE752. In the previous session, we had the topics related to an induction motor, that is the foundation and leveling of an induction motor during the installation. Now, compared to the transformer, we gave much importance to the foundation requirement for an induction motor because of its rotational movement. It will be operating, depends upon the design condition, maybe 1500 RPM or maybe the 3000 RPM, hence vibration gets caused in the motor. These vibrations should not be passed on to the other machines or maybe the surrounding walls if these induction motors are installed indoor. That's why we are going to provide a foundation asset. We are going to provide a foundation. Therefore, this foundation, the concrete mixture, it should be done according to the standard provided by Indian standard. That afterwards we came to know about the shimming, the meaning of a shim. That is, it is a steel piece of metal piece. It is connected between or may be provided between the base plate and the bed plate of any machine to rise or lower the machine height so that the proper alignment can be done if you are going to couple the motor and the generator set. Then afterwards we have seen that the bed plate provided for that particular motor maybe a motor generator set may be complete to one part, or maybe it depends upon whether it may be separate for motor as well as the separate for a generator as such. Generator, that what you have seen in the previous class. In this class, we are going to go further the need of a drying and the different methods of drying process. Then we are going to have the mechanical, the checkups of once again here, the induction motor, the shaft alignment process. Therefore, we are going to give a concentration on need of drying process and the different methods of drying and shaft alignment process that we are going to have it for an induction motor. Now, after the class, the student should be able to know about the need of drying, why the drying process is essential and the different methods of drying the process that are involved in case of the induction motor. Then afterwards, the shaft alignment, how one can align the shaft for the proper shaft alignment as well as the coupling between the motor as well as generator set. Now, let us go with the drying of an induction motor. As you already know the meaning of a drying in case of the transformer, similar fashion here also, the insulation provided in the rotating machine will be having a property of absorbing the moisture content. That's why we call it as a hygroscopic in nature, and tries to absorb the moisture content when they are not carrying the current. Suppose if I keep the induction motor without any of the installation as such, at the time the moisture may get enter into the insulating medium that are provided in case of the induction motor. It is going to happen when we keep the induction motor without allowing the current flow to that one, or maybe not in operation condition. This absorption of the moisture content by insulation reduces insulation resistance and withstanding ability of the winding. Once the moisture gets absorbed by the insulation, it loses some of its electrical property, hence some of the other time application of voltage, it may become a conducting part. It is always essential now when it becomes maybe when it absorbs the moisture content, it is always essential to remove the moisture content so that I can keep the insulating properties as it is when it is provided during the manufacturing condition or maybe design condition. Therefore, the principle used in drying out of motor is to apply the heat continuously for a considerable amount of time so as to remove any moisture content which may have entrapped in the winding. Once the moisture gets absorbed, as I said already, insulating properties reduces. Hence, to bring back that insulating property to original position, it is always essential to remove the moisture content. How to remove the moisture content? Is the principle applied is allowing a current through the induction motor so that we can apply the heat continuously for a considerable amount of time, as a 6 to 7 hours, 8 hours, to remove the moisture content which may be entrapped in the particular induction motor insulating medium. Not only induction motor but all electrical equipment, not only I am speaking about the induction motor, but all the electrical rotating machines and the static machine are to be dried out when the insulation resistance becomes less than the permissible limit specified by the Indian standards. Now, once the insulation resistance is measured here, if it is according to the Indian standards for a particular capacity of an induction motor or maybe electrical equipment, at the time we do not require any of the drying process, We'll see that one. Next, we'll go to the next part. Before the start of a drying process, a log sheet is maintained. Now, I cannot carry out the drying process as it is whenever I like it. First, I have to check the insulation resistance. Then, if it is less than the permissible limit specified by the standards, at the time, I need a drying process. That is, method has to be selected depending upon the capacity of a induction motor. Therefore, before start of a drying process, a log sheet is maintained which provides the following information. That is, a log sheet should be there. It should have the following information. That is, you can see that the technical specification or particulars of the machine. Then that particular log sheet, you have to have the technical details of the machine which is under a drying process, like a rated voltage and a rated frequency, at what rated voltage is there, and rated frequency, rated capacity, and the rated current. Then connection diagrams and the number of windings. Therefore, technical details of the motor or maybe equipment which comes up for the drying process or are noted down in a log sheet. The technical particulars about the connections for drying out. Ambient temperature, the initial value of insulation resistance, date and time of start, and the operator name. All this information should be there in case of this log sheet. All information should be there in this log sheet. Just like, I don't know how many people you might have seen the hospitals, whenever you get into the inpatient, as get admitted as the inpatient, every inpatient will be having a log sheet. What is the tablet given? What are the precautionary measures he has to take it? It's helpful for the next person or a doctor who can monitor that particular log sheet accordingly, that the medicine to be given. Similar fashion, the process of drying will be sometimes goes together 2 or 3 days. At that time, the person who comes for the shift wise will get into this log sheet. Accordingly, necessary arrangements are made to drying out process. Precaution. Let us see that what are the precautions that we need to take it before the drying process. The precautionary measures to be taken during the process of drying of an induction motor as follows here. The proper ventilation should be provided to carry off the moisture and ensure the circulation of hot air. That is, if you want to do any of a drying process, the equipment will be properly ventilated so that it can carry off the moisture content, ensure that the circulation of hot air. During the drying process, the motor should not be left unattended. Every time that should be monitored by an operator. That is, one person should be there during the drying process. It should be done with the help of a skilled technical person. You should know that the variation of voltage, all the technical related terminologies and terms you should know. That's why we say that drying process should be done with a technically skilled persons. During the process of drying, the temperature of the winding should not be allowed to go behind or maybe exceed the 90 degrees centigrade. That is one of the precautionary measures that has to be taken here. That is, any time during the drying process, the temperature inside the induction motor or a winding should not go behind 90 degrees centigrade. During the process of drying, the reading of a temperature, insulation resistance should be taken at least once in an hour in order to see how the drying process is going on or maybe progressing. Every time, maybe the half an hour, depending upon the standards or maybe depending upon the manufacturer guidelines, every time the temperature of winding should be noted down, maybe once in half an hour or maybe once in 1 hour, or maybe insulation is measured accordingly at every time, depends upon the frequency of measuring that set by a guidelines, or maybe depends upon the amount of moisture content it might have observed. Now we'll see the different methods of drying. The first method is by drying a chamber and a resistor heater. Resistor heating, that is here that we're going to use one chamber in which you're going to keep the induction motor inside. The volume of the particular chamber, it is approximately 3 to 4 times of the volume of the particular induction motor, which is to be dried out. Then we're going to use a heater here. Heater, it is a resistor heater. You can see the resistor heater of certain capacity, depends upon the capacity of the induction motor. Therefore, here we take the induction motor, remove either end rings of induction motor, we keep in case of the heating chamber. Then afterwards, using the heater, which is supplied by single phase supply, we heat this heater. Once it gets heated up, we blow the air across that particular heater so that the air gets dried out, maybe heated up, that hot air will be allowed into the induction motor to drying the process of the drying chamber as such, so that when hot air moves inside the induction motor cabinet or maybe the motor or maybe the particular chamber, it removes all the moisture content which might have entrapped or maybe absorbed by insulation resistance or maybe insulation, and which will be let off. That's why we say that the proper ventilation is to be provided. Proper ventilation is to be provided. Simple, this one is nothing else as this one. Take the induction motor, keep it inside the chamber and heat the heater, maybe supply the single phase supply, so that it gets heated up. Then allow the air across the resistor heater and allow the inside the hot air in the chamber and removes the moisture content. Similar fashion, it will be dried out. Now the rating of the heater, we'll see that what is the rating, what the capacity of that heater I should take it in terms of kilowatt. The rating of the heater used for the above method of drying obtained by the equation, that is what is the kilowatt capacity of that heater that I should use it. I cannot use a 10 kilowatt resistor for drying out of 1 HP motor. It depends upon the motor size and capacity. Therefore, P equals to 0.025 into T2 minus T1 kilowatt per volume, where P is a rating of the heater, that is should be allowed in terms of the kilowatt. Then T1 is the ambient temperature, that is where you are going to dry out on the drying process, that is, and T2 is the temperature of the hot air, what you want it. Likewise, now typical, this is the equation from which you can obtain it. Now once if you know the ambient temperature at what hot temperature of the hot air you require. Now sometimes it may not be possible to have the ambient temperature. At the time we go with this method. The typical rating of the heater for drying as a percentage of machine rated or as shown in the figure. That is, I'll fix up the rating of the heater in terms of the percentage of capacity of the induction motor. For example, here you can see that up to 500 kilowatt induction motor, I can use a 3% of 500 kilowatt, that is 1500 watts, or 1.5 kilowatt heater is sufficient to dry out the induction motor of up to 500 kilowatt. Similar fashion, when the capacity increases, the percentage of the rating of the heater required maybe goes to 2 to 3% of maybe 1000 or maybe 500. Likewise, if the machine rating is at 1000 to 10,000, at the time I may require the capacity of the resistor heater around 1.5 to 2.5 depending upon the capacity there. For the larger capacity machines, heater, the blowers of 25 kilowatt are used. 25 kilowatt are used. As it increases the capacity, this percentage may not be working out at the time. Heater blowers of 25 kilowatt are used for larger capacity induction motor. For larger capacity induction motor. Otherwise, as specified by the standard specifications. This is one method of. Let us go for the second one. It is drying by radiating lamps. By reading the radiating lamp. In case of this one, once again, we'll be having a heating chamber. Then we take the induction motor, either both endings are removed, and this chamber will be provided with bulbs. You can see the bulbs. For this one, the single phase supply will be given. As you know that whenever the incandescent bulb burns out or maybe glows out, we get a heat energy. That heat energy is similar fashion what you have seen it here in the previous drying method. Heat developed will remove the moisture content which might have absorbed by induction motor insulation what is provided in the particular rotor and the stator winding of the motor as such. This is the simplest method. Now we can dry out the stator separately and the rotor separately as such. Rotor separately and stator separately by giving the supply to the two bulbs. That's why we get the radiating lamps. In this also, the temperature should be kept well within the permissible limit of the particular withstanding ability of the insulation. Now, this is everyone knows probably you people might have conducted the experiment in case of the laboratories. That's why drying of an induction motor with a short circuit the current method, or maybe normally we call this one a blocked rotor test. Blocked rotor test. What you do it here? Here we block the rotor. Block the rotor and we apply reduced voltage until the short circuit current flows. When the short circuit current flows, the heat depth gets developed because of flow of current. Hence, the temperature of the winding goes on increases. Hence, it can remove the moisture content. Now, this is to be done according to once again the standards. Sometimes in the standards they will be specifying what is the voltage should be given, or sometimes what should be the current that should enter into the induction motor. That's here they say that 50% you should apply the voltage, the reduced voltage such a way that only 50% of the rated current should flow. But in case this one also, you should take a precautionary measure that winding temperature or maybe temperature developed in case of the induction motor should not go behind the specified value by the customer, or maybe that is a manufacturer, or maybe manufacturer guidelines. These are the three methods of drying what you see. Now we go to the shaft alignment. It is always essential to have the proper alignment. Now let us go for why the shaft alignment is required. When the motor is existing alone, I no need to have the shaft alignment as such. This comes into picture whenever you are going to couple the induction motor to the other equipment, like maybe the drive, or maybe to the generator, maybe the DC generator, or maybe AC generator. At the time, shaft alignment it comes into picture. This also helps in providing the proper air gap between the rotor and the stator for the induction motor. It is always essential to have the proper alignment when we want to couple the motor and the generator. The misalignment will affect the operation of the machine completely. Misalignment, there are a lot of complication comes into picture if you are not properly aligning the motor and the generator. If the alignment is not done properly, there will be more vibrations in the set and it may damage the bearing and also shaft of the motor completely. That is, the bend structure of the motor comes into picture whenever you doesn't align the motor and generator properly. Therefore, proper alignment is essential. The shafts of a driven and a driving machine are aligned by three different methods. There are three different methods are available to couple either the motor with generator or motor with the alternator of maybe the DC generator, maybe AC generator. Therefore, three methods are the axial positioning of the shaft. First, you have to do the axial positioning, then the paralleling of the shaft, and the last one method is the centering of the shaft. If you do all the three, then we say that they both the driven and the driving machines are properly aligned, then you can have the proper coupling. If you are not done any of these of three methods, that at the time the alignment may not be proper, at the time unwanted the vibrations comes into picture, which will hamper the operation of induction motor by damaging the bearing as well as the shafts. We'll see one by one. The first one, the axial positioning of the shaft. The first method of the shaft alignment is axial positioning. It's also called as offset alignment. Offset alignment. You can see that letter 3, this thing are there. In this, a level gauge is used to bring the axis of the machines in line with each other, and this is called as the axial positioning. You can see the first figure. See, this is let us consider this is, I will take it as a motor, and this I will take it as a generator. You can see this motor, the shaft is a little bit upper compared to this machine as such, this machine. Now here I cannot couple it now because the height at which the two shafts are there are at a different levels. There is a difference between the height of this one and the height of this one. Small difference is there with this seeing the figure. I cannot decouple it now. That's why the axial positioning comes into picture. Axial, the position. It is a wrong thing as such. I cannot couple it. That's why it is an improper alignment. What should be the proper alignment? The correct alignment, as you can see that the axis of the shaft and the axis of the shaft are totally different. Now, after making the alignment using the offset alignment or maybe axial positioning of the shaft, you can see that the axis of the shaft are in line with each other. Hence, I can couple it now properly. The coupling can be done. That is done by, you can see that this is the gauge, level gauge. What you can see that you can see this figure, and you see this figure. This one is upper, and this one is the bottom. You can have the slight gap here. How to rise that? That's why the shimming process came into picture in the last class we have studied. That's why I'll rise here the height of this machine by shimming process, so that the axial positioning can be obtained. By the axial positioning may be the obtained. You can see that one. That is by shimming process. I can rise this one. That's why it has come into picture. This way is the axial positioning of the shaft can be done. This is the first method. Let us go to the paralleling. What is the meaning of paralleling? You can see that the first figure, the paralleling of the shaft is done with the help of the feeler gauge, inserting them between the machine coupler. You can see that one. This machine is, the axis is like this, but this machine has a little bit of a bent structure as a bent the structure. Bent structure. Now see, the correct alignment is this one. Once again, the two axes are the same thing. Therefore, this is done with the help of the feeler gauge. You can see the feeler gauge. This is done with the help of the feeler. We'll see that how the feeler gauge comes into picture to make a paralleling of the shaft. Paralleling of the shaft. You can try to remember this figure. This is the one shaft, the other shaft, and the coupling should be done between here. That I am going to have the paralleling to this one with the help of the feeler gauge, inserting them between the two couplings at a different clock positions. The procedure, we can see it in the next slide. The procedures to be followed for the paralleling of the shaft as follows. Obtain the feeler gauge reading. I already said that feeler gauge. Obtain the feeler gauge reading by inserting the gauge in a 12 o'clock position and the 6 o'clock position between the coupler. That is, I told you already to remember that the previous slide, last figure, I am going to insert the feeler gauge in the 12 o'clock position and the 6 o'clock position. We get some reading. Obtain the algebraic difference. algebraic difference. I think everyone knows what is the meaning of the 12 o'clock position and the 6 o'clock position. Therefore, I am going to insert the feeler gauge at 12 o'clock position and 6 o'clock position, and I'll find out the algebraic difference, and that will equate it to x. Then I'll rotate both the shafts by 180 degree. By 180, I'll shift the position of the shaft 180 degree. Then once again I insert the feeler gauge at a 12 o'clock position and 6 o'clock position. I'll find it out as the x1, algebraic difference as x1. If the algebraic difference, the first one and second one are same, then we say that shafts are properly aligned vertically. I can say that if x1 becomes to x2, then I can say the shafts are aligned vertically. In the similar fashion, in the same way, I'll find out the algebraic difference once keeping the feeler gauge at 3 o'clock position and 9 o'clock position, and I'll shift 180 degree the shaft, and once again I insert the feeler gauge and find out the algebraic difference at 3 o'clock and 9 o'clock position that are noted as y and y1. If the algebraic difference y and y1 are same, then I say that the shafts are aligned horizontally. Shafts are aligned horizontally. In this way, I can align properly vertically as well as horizontally by the paralleling of the shaft. This is the second method. Let us go for how to do the centering now. This is done with a clock gauge. You can see that this is the shaft of the shaft of the others. You can going to have the gauge here that you can. In this, the clock gauge is used, which is clamped on one half of the coupling, and clamped here with the gauge needle and the other half coupling. You can see that gauge needle and the other half coupling. Both half couplings are rotated through a full revolution. Then gauge readings are taken at 12 o'clock, 6 o'clock, 3 o'clock and 9 o'clock positions. That is, I am going to rotate this clock one revolution. I'll take down the readings of the gauge at 3 o'clock position, 6 o'clock position, 12 o'clock position and 9 o'clock positions as such. The alignment is said to be proper if all the clock readings are same. The alignment is said to be proper and will be centered. That is, all the readings are same. 12 o'clock position, 6 o'clock, 3 o'clock and 9 o'clock positions. If they become same at all the clock position or all the revolution, then I can say that the shaft is centered properly. This way we can have the shaft alignment for induction motor before coupling as such. Also, sometimes to know the gap difference between the rotor and the stator windings. Now this way, let us come to the summary that what you studied today is the need of a drying, why the drying method is essential, or the drying process is essential. Then afterwards we have seen the three methods. The first method is a heating chamber as well as the heater. The second method using the lamps. Third method is the block rotor method and the short circuit method as such. Then afterwards we have seen that the need of the shaft alignment. This comes into picture whenever you want to have the coupling of the motor as well as the generator as such. There are three methods what you've seen: the axial position, the paralleling and the centering of the shaft. If you do all the three, then I can couple the motor as well as the generator. All these topics what you studied today comes under the level of understanding as well as remembering. That's why level 1 and level 2. For all these above topics, you can refer the textbooks written by two authors, S. Rao with the title Testing and Commissioning, the Operation and Maintenance of Electrical Equipment, and also you can see one more textbook written by Dr. R. L. Chakasali with the title of the book as Testing and Commissioning of Electrical Equipment. Thank you.